You're scrolling late at night and a video autoplays. A robot is smiling at you. It has skin. It has eyes that blink. Something about it is wrong. You can't say what. Your stomach tightens before your brain even catches up. You scroll past it fast, without really deciding to. It feels irrational. It isn't. But the real answer is far stranger than creepy robot. You've just met one of the oldest alarm systems your species ever built. In 1970, a Japanese robotics professor named Masahiro Mori noticed something strange happening in his lab. The more human his robots looked, the more people liked them, up to a point. Then, right before a robot became almost perfectly human, something flipped. People didn't feel comfort anymore. They felt dread. Mori sketched it as a graph. Comfort rises steadily as a robot gets more human-like. Then it crashes into a deep pit. Then, only once the robot becomes indistinguishable from a real person, comfort climbs back out. He called that pit Bukimi no Tani. You know it today as the uncanny valley. For decades, this was just a hunch, a sketch on a page. Then scientists started testing it for real. In 2011, a neuroscientist named Issei Sagan, working at UC San Diego, put people inside an fMRI scanner and showed them three things: a human moving normally, a cartoonish robot moving like a robot, and an android built to look almost perfectly human, but moving with the slightly off motion of a machine. Your brain barely reacted to the first two. Robots are supposed to move like robots. Humans are supposed to move like humans. No conflict there. But the android lit up a specific region tied to predicting movement. Your brain expected one thing and got another. That mismatch wasn't just noticed. It was flagged as an error. That's the part most people get wrong about the uncanny valley. It was never really about robots. Carl McDorman, a researcher at Indiana University, spent years trying to figure out what specifically triggers the drop into the valley. Is it the eyes? The skin texture? The way a mouth moves out of sync with words? His experiments kept pointing to the same culprit. Mismatch. Not ugliness. Not robotic simplicity. A face that is human in one way and not quite human in another, layered on top of each other at the same time. A voice that's warm, but a mouth that barely moves. Skin that looks soft, but eyes that never blink at the right moment. Your brain isn't repelled by the robot. It's repelled by the contradiction. Why would a contradiction feel dangerous? Here's the twist. For most of human history, there was no such thing as a lifelike robot to react to. So this circuitry wasn't built for machines at all. It was built for something else. Something your ancestors actually encountered. A body that looks alive, but moves wrong. A face that looks like your tribe, but behaves like a stranger's. A person showing symptoms of a disease that hasn't fully announced itself yet. Researchers studying disgust and pathogen avoidance, including work led by psychologists such as Joshua Tiber, have shown that humans carry a finely tuned system for detecting subtle signs of illness in other people, sometimes before conscious awareness even catches up. A slightly wrong gait, skin that looks pale in the wrong way, eyes that don't track normally. These are not robot problems. These are corpse problems, illness problems, deception problems. Your ancestors who felt a jolt of unease around a person who seemed off were often the ones who survived the next outbreak, or avoided the next predator wearing something unfamiliar, or noticed the next liar before being betrayed. That unease wasn't superstition. It was an early warning system, running quietly under conscious thought, tuned by generations of consequences. And that system doesn't know the difference between a diseased ancestor and a very good CGI character. This is why certain films spent hundreds of millions of dollars on visual effects and still got the same complaint from audiences. Not, the graphics look bad. Something stranger. The graphics look wrong. A character can be rendered with extraordinary detail, individual pores, realistic hair, perfect lighting, and still trigger that same drop into the valley, because one tiny element, usually the eyes, moves in a way that doesn't match everything else. Your brain doesn't grade on effort. It grades on coherence. Psychologists Kurt Gray and Daniel Wegner tested a related version of this discomfort. They found that what unsettles people most isn't a machine that looks human. It's a machine that seems to have a mind, something that appears to feel, to want, to suffer, without actually being able to. That gap between apparent consciousness and actual consciousness turns out to be one of the most unsettling things a human brain can process.